Question number 15. Question number 15 is a dimensionally consistent relation for the volume V of a liquid of coefficient of viscosity eta flowing per second through a tube of radius r and length L and having a pressure difference P across its N is this. First option here, volume V is equal to pi p r to the power 4 by 8 eta L. Second option here, pi eta L by 8 p to the power 4. Third option here, V is your 8 p eta L by pi r to the power 4. And the fourth option here, V is equal to pi p eta by 8 L r to the power 4. So we have to see which one of the four options is dimensionally or consistent. So see the solution here. So all of the options we will verify. So here V is the volume. So first option, first see the first option. First option, V is given as pi p r to the power 4 by 8 eta L. Pi p r to the power 4 by 8 eta L, where V is the volume. This is your volume, and this P is here pressure, R is the radius of tube, L is the length of tube, and eta is your viscosity. So we would like to check it, either dimensionally it is correct or not. See, volume left hand side, dimension of volume your L cube. Now from here if we are looking dimension of pressure, as we know pressure is your force per unit area. So dimension of force is mLT minus 2, area L square. This is dimension of pressure. R radius L to the power 4 by dimension of eta and dimension of length. Dimension of length is okay, L. Now dimension of viscosity. How to get dimension of viscosity? As we know, force F is equal to eta A dV by dy. So dimension of viscosity, force dimension your mLT minus 2, dimension of viscosity area L square, velocity LT minus 1, and dy is your L. So dimension of viscosity here, 1 LL cancel here, mLT minus 2, LL cancel here, L square T minus 1. So finally dimension of viscosity or M, L minus 1, T minus 1. So this is the dimension of viscosity which we can substitute here. So M, L minus 1, T minus 1. So check it, the dimension of your left hand side and right hand side. M and M cancel here, L to the power 4 here, and this is here L square. So we will get here L to the power 4 and 4 plus 1 5, and here we are getting L square. So M0 L cube T minus 2 here, and here we are getting T minus 1. So this become your T, L cube T minus 1 and minus 1, so T minus 1, the volume per meter cube. So this here, in fact, as per the given question, so this is the your V is the volume of fluid passing per second, the volume per second. So if volume per second, so dimension of this will be your t to the power minus 1. So one more term we can use here, t minus 1. So then the left hand dimension is equal to your right hand dimension. So correct option, your answer number 1 is the correct option. Now come to the next one, question number 16. Now question number 16. In this question it is given, from the dimensional consideration, which of the following equations are correct? Option number 1 is t is equal to 2 pi root over r cube by gm. Option number 2 is t is equal to 2 pi root over gm by r cube. Option number 3 is t is equal to 2 pi root over gm by r square. And option number 4 is t is equal to 2 pi under root r square by gm. Now we can check it. So one by one we will check it. So option first given, t is equal to your 2 pi r cube by gm, where t has usual meaning, time period, r is the radius of the earth, g your earth gravitational constant or gravitational constant, and m is the mass. So dimension of left hand side your t. Now see the dimension of right hand side. So first we will check the dimension of g. See, as we know, F is equal to G m1 m2 by r square. So dimension of F is your ml t minus 2. This your L square, that is your dimension of G. Dimension of m your m square. So dimension of G will be here m minus 1 L square t minus L cube and t minus 2. This is dimension of G. So check it. Left hand side, dimension of m0 L0 t1. Right hand side, dimension of r cube. R is your length cube by G into m. G into m when we are writing L cube t minus 2. This is your whole power 1. So check it. L cube cancel here. So then it become your t. So what we found in the first option itself, the first option itself is the correct option, because left hand dimension is equal to your right hand. So no need to do the other option because single correct option is there. So our answer is your answer number, option number 1. The first is the correct option. Now come to the next problem, question number 17. Now see the question number 17. In the 17th question we have to find the question is that the dimensions of A and B in the expression P is equal to A minus T square by Bx, where P is the pressure, X is the distance and T is the time, R. First option your mt minus 2. Second option your m square L t minus 3. Third option your ml cube t minus 1. Fourth option your L t minus 3. See the first of all expression. So our expression is given as P is equal to your A minus T square by Bx. A minus T square by Bx, and we have to find dimension of A by B. This we have to calculate, where P is the pressure, T is the time and X is the distance. First of all, two quantity can be added or subtracted only when those two are the dimensionally same. So if we are adding or subtracting time with A, then A must have dimension as a time dimension. So dimension of A will be your T square. And now, so this your have dimension T square, this your L. So now we can write from here dimension of pressure is your force per unit area. The force is your mLT minus 2, area your L square. This is your pressure. That is equal to dimension of T square. Dimension of B is your, we have to find, X have dimension your L. So dimension of B we can write from here. Check it. 1L, 1L cancel, 1L, 1L cancel. So dimension of B is equal to your m minus 1 and t to the power 4. This is dimension of B. So dimension of A by B. So dimension of A by B, dimension of A is your t square and dimension of B your m minus 1 t to the power 4. So this become your m t minus 2. This is the dimension of A by B. So as per our given option, option number 1 is the correct option. So hence answer is your answer number 1, or option number 1 is the correct option. Now come to the next problem. Now see the question number 18. Question is given as if the radius of the sphere is 5.3 plus minus 0.1 centimeter, then percentage error in its volume will be. So option number 1 is 3 into 6.01 to 100 by 5.3. Option number 2 is 1 by 3 into 0.01 into 100 by 5.3. Option number 3 is 3 into 0.1 by 5.3 into 100. And option number 4 is 0.1 by 5.3 into 100. Check it how to solve this problem here. So in this question here, radius of the sphere is given your 5.3 plus minus 0.1 centimeter. This is the radius is given. So as we know volume V is your 4 by 3 pi r cube. So percentage error in volume can be written as delta V by V into 100, which is equal to 3 delta R by R into 100. 3 delta R in this term is called delta R, which is equal to 0.1. R value or 5.3. This is your R and this is your delta R. R is your 5.3 into 100. This is the percentage error in the volume. So finally this is the option. So answer your option number 3. 3 into 0.1 by 5.3 into 100. So correct option your option number 3. So which is the correct one. Now come to the next question, question number 19. Now question number 19 is the pressure on a square plate is measured by measuring the force on the plate and the length of the sides of the plate. If the maximum error in the measurement of force and length are respectively 4% and 2%, the maximum error in the measurement of pressure is first option your 1%, second option your 2%, third option your 3%, and the fourth option your 4%. See the question here. It is given here a square plate like this. So this is also L, this is also L. Some force must be here like this. So pressure is equal to your P is force, F per unit area, L square. So P is your F by L square. So percentage error in the pressure measurement. So percentage error in pressure measurement. In pressure measurement, delta P by P into 100, which is equal to delta F by F into 100 plus 2 times delta L by L into 100. This is the pressure measurement. So as per the given data here, the measurement in error in the measurement of force is your 4%. Error in the measurement of force is your 4%, while error in the measurement of length is your 2%. So plus 2 into 2, so this become your 8. So finally, the percentage error in the measurement of pressure is your 8%. The answer should be your 8%. So option is your 4 option can be correct here. Option number 4. Now come to the next problem, question number 20. Now see the question number 20. It is given, while measuring the acceleration due to gravity by a simple pendulum, a student makes a positive error 1% in the length of the pendulum and negative error of 3% in the value of the time period. So his percentage error in the measurement of G by the relation G is equal to 4 pi square L by T square will be. Option 1 is 2%, option 2 is 4%, option 3 is 7%, and option 4 is 10%. Now see how to get the solution of this. As G is equal to your, can be written as 4 pi square L by T square. So percentage error in G can be written as delta G by G into 100, which is equal to, from this expression, delta L by L into 100 plus 2 times delta T by T into 100. So this term is give the error in the measurement of length, this term give the error in the measurement of time. So as per the question, error in the measurement of length is your 1% and error in the measurement of time is given here 3%. So 2 into 3, so total your 7. So we can say the error in the measurement of G is 7%. So our answer is your 7%, and the option third is matching with our answer. So correct option your option number 3. Now come to the next problem, question number 21. Question number 21, question is this: the circular scale of a screw gauge has 50 division and pitch is 0.5 millimeter. Find the diameter of a sphere having main scale reading 2. Option number 1 is given 1.2, option number 2 is 0.25, option number 3 is 2.20, and option 4 is data is insufficient. See, in the question number 21, main problem in this, whenever we are taking reading from any of the instrument, either your vernier calipers or from a screw gauge, the first thing the reading comes here, where in case of vernier calipers, vernier scale is lying between the two main scale division. That is the one part, and then we have to check the which of the vernier scale calibration coincide with the main scale. Similarly, in case of a screw gauge, first we have to check it the circular scale 0. The circular, where is our circular scale 0, or at which point this reference line of the main scale is lying with the circular scale. That is the one part. Then we have to check the which division of the circular scale coinciding with the reference line. But in the given question here, in the given data, only they are giving the main scale reading. They are not telling anything about the where is the reference line of the main scale lying, or which division of the circular scale is along the reference line. That's why data is your insufficient. We cannot able to calculate the data. So option your answer 4. Okay, now see the question number 22. It is based on the matching. To match the following in the table 1, A is given torque, B is given coefficient of viscosity, C is given elastic potential energy, and D given bulk modulus of elasticity, while in the table 2, P given ml 1 t minus 2, Q given ml square t minus 2, R given ml minus 1 t minus 1, S given ml minus 1 t minus 2. So our options are: first option, A matches with B, B matches with Q, C matches with R, D matches with S. Our second option is A matches with S, B with P, C with Q, D with R, and the third option here, A with S, B with R, C with Q, D with P, and the fourth option here, A with Q, B with R, C with Q, D with S. Now we have to select the correct option. Let's see how to solve. First, see in the column 1. In column 1, we would like to write all the parameters A, B, C, D. A is here torque. First, we will find the torque value. Torque, as we know, in terms of your only magnitude, force into displacement or position vector. So dimension of torque is your R into F. R is your L, F is your ml t minus 2, the ml square t minus 2. This is the dimension of torque. Similarly, if we are looking the next point here, coefficient of viscosity eta or viscosity eta, that eta is nothing F by area dV by dy. Then F, dimension of F ml t minus 2, dimension of A, area L square, dimension of dV by dy, V is your L t minus 1, and this is your L. So finally we can say dimension of eta here, we can check it, 1 L cancel, 1 L and 1 cancel, M L minus 1 t minus 1. This is the dimension of viscosity. Next is the elastic potential energy. Elastic potential energy, so that dimension here ml square t minus 2. This is the relation for potential energy. Now next is the D option, that your bulk modulus of elasticity. Bulk modulus. Bulk modulus B is given as delta P by delta V by V, and this is nothing pressure, change in pressure, pressure your force per unit area, force ml t minus 2 by area L square, this will be your m L minus 1 t minus 2. Now we can select one. Torque ml square t minus 2, C in the column 2, ml square t minus 2, one option your is Q given. So this option your Q in the column column 2 we can matches. Now viscosity ml minus 1 T minus 1, ml minus 1 T minus 1, that option your R. So B is your R. Next is your C, elastic potential energy, that is also our coming here ml square T minus 2, which is equal to your our option your Q. So this is also your Q. And fourth is your bulk modulus ml minus 1 T minus 2, and given option your S. So S. So A matches with the Q, B matches with R, C matches with Q, D matches with S. So these are the correct option, and among the 4 option, our fourth option is matches with the given option. So answer is your 4. Fourth one is the correct option. Now come to the question number 23. The question number 23, this is also based on the matrix matching. Match the following. Table 1, A given is the stress into strain, B given your YA by L, C option is given your Y into P, and D option is given your FL by A into Y. And in table 2, P is given your joule, Q is your Newton per meter, R is joule per meter cube, S is your M. The given options is your first your A matches with S, B with P, C with Q, D with R. And second option A with R, B with P, C with Q, D with S. Third option A with R, B with Q, C with P, D with S. And the fourth option A with P, B with Q, C with R, and D with S. Now we have to select the correct option. See, first we will check the table 1. In the table 1, if we are looking the A option, A is your stress into strain. If I am looking the dimension of stress into strain, stress means here force per unit area. Strain does not have any dimension. Force per unit area. The force is nothing, Newton per meter square. So this is the dimension of your stress into strain. And this, if we want to convert this, that we can convert in the another form. Newton further written as any force into distance by meter cube. So we can say force distance here, joule per meter cube. This is one of the option. B. In the B it is given YA by L. Y here your Young's modulus. Y is your Young's modulus. A is the area, L is the length. The Young's modulus further written as stress by strain into A by L. Now, stress again. Stress dimension your force per unit area. So force per unit area cancel. Force means here Newton per meter. The Newton per meter, and this relation can be said as N by M. Next one, our relation is your C. In the table 1, C option your Y into L cube. So Y again Young's modulus. Y into L cube. Young's modulus here stress by strain into L cube. Strain does not have any dimension. Stress, again, force per unit area L square into L cube. Force into L, that become a joule, J. This is your option for third. And D, in the D, FL by A into Y, FL by A into Y. So F by A into Y, see, force by A, so that we can write stress. Young's model your stress your force per unit area into strain. So what we are getting here, FF cancel, AA cancel, strain does not have any dimension, that is equal to L, L is nothing, your M. So these are the different units of these values. So see the first option, stress into strain, joule per meter cube. If we are looking the column 2, in the column 2, joule per meter cube is in the option R. So this is in the R. Similarly, Newton per meter in the column 2, Q, and in the column 2, J is your nothing in option P, and meter is the option your S. So check it. A matches with R, B matches with Q, C matches with P, D matches with S, and this is the option. So see, check it. A with R given in the B with Q, C with P. So our correct option is option number 3. So hence third option correct. So answer we can write your third option, which is the correct option. Now come to the next question, question number 24. So question number 24, in 4 complete revolution of the cap, the distance traveled on the pitch scale is 2 millimeter. If there are 50 divisions on the circular scale, then calculate the pitch of the screw gauge. Option first is given 0.5 millimeter, option 2 is given 0.3 millimeter, option 3 is your 0.2 millimeter, and option 4 is 0.4 millimeter. So now see how to do this. First, pitch. Pitch means distance travelled by the circular scale over main scale in one rotation. Distance travelled by circular scale over main scale in one rotation. Distance travelled by circular scale over main scale in one rotation. So this does not depends on the number of division on a circular scale, doesn't matter. So as per the question, it is given in 4 rotation 2 millimeter it has travelled. So in one rotation, so pitch in 4 rotation 2 millimeter. So in one rotation 2 by 4. So it should be a 0.5 millimeter. So answer is your pitch is equal to 0.5 millimeter. So our option number 1 is the correct option. So answer is your 1 is the correct option. Question number 25. Vernier calipers having one main scale division is equal to 0.1 centimeter is designed to have a least count of 0.02 centimeter. If n be the number of division on vernier scale and m be the length of vernier scale, then assume that vernier calipers is calibrated such that length of n minus 1 main scale division is equal to n Vernier scale division. So, we have to find value of n and m. In the first option it is given n is your 10, m is your 0.5 centimeter. The second option it is given n is equal to your 9, m is equal to 0.4 centimeter. In the third option n is equal to 5, m is equal to 0.4 centimeter, and in the fourth option n is equal to 10 and m is equal to 0.2 centimeter. Now, see how to solve this problem. See, as we know, least count is equal to reading of one main scale division minus reading of one Vernier scale division, and it is given in our question least count value is 0.02 centimeter. 0.02 centimeter, this is given in the least count, and reading of one main scale division, that is also given 0.2 centimeter. Reading of one main scale division is given 0.1 centimeter. So, minus reading of one Vernier scale division. See, so reading of one Vernier scale division is equal to your 0.1 minus 0.02 centimeter. So, this will be your 0.08 centimeter. So, this is the reading of one Vernier scale division, and it is given n be the number of division on Vernier scale and m be the length of Vernier scale. So, this is also equal to n by m is the length of Vernier scale, that is the total reading of the Vernier scale, m by n centimeter, and this is also given n minus 1 main scale division is equal to n Vernier scale division, n minus 1 the main scale division. So, reading of one main scale division is given here 0.1, and that is equal to your n minus 1 main scale division. See, first equation from here, so that give us m is equal to 0.08 into n. This let your first equation, and second equation we can get from the relation one C n Vernier scale division is equal to your n minus 1 main scale division. So, let if we are looking this one n Vernier scale division, let we are looking the 5 Vernier scale division reading. For Vernier scale division reading is your each division m by n, which is equal to your n minus 1, and 4 main scale reading your 0.1. So, from that if we are simplifying, 5m is equal to your 0.4n, or we can say 50 by 4 or 25 m is equal to your 2n, and this we can substitute. So, from first and second, let us substitute the value of this and we will get the relation between these two. So, 25 m is equal to your 2n. From first and second, we will get the option number 3 is the correct option. Is the correct option. In the question number 26, if force, length and time would have been the fundamental units, that would have been the dimensional formula for mass. First option is your Fl minus 1 T minus 2. Second option Fl minus 1 T2. Third option Fl T minus 2. Fourth option F. See, as we know force is equal to your mass into acceleration. This we can write. F is the fundamental, mass we have to find m, acceleration your L by T square. So, dimension of m, mass is equal to F L minus 1 T square. So, according to this, our option number 2 matches with the given option. So, hence answer 2 is the correct one. This is the question number 26. Now, see the question number 27. See the question number 27. Each division on the main scale is 1 millimeter. Which of the following vernier scale gives vernier constant equal to 0.01 millimeter? First is your 9 millimeter divided into 10 divisions, 90 millimeter divided into 100 divisions, 99 millimeter divided into 100 divisions, and fourth option 9 millimeter divided into 100 divisions. So, first of all, given parameters. Given parameter is this. This is a main scale. In one division, each division your main scale is 1 millimeter. So, each main scale division is equal to your 1 millimeter, and the least count in vernier constant is least count. The least count is given as least count is equal to your 0.01 millimeter. 0.01 millimeter. So, least count is equal to your 1 main scale reading minus 1 vernier scale reading. So, that is your 0.01 main scale reading your 1 minus 1 vernier scale reading. So, 1 vernier scale reading, that is equal to 1 minus 0.01, which is equal to your 0.99. So, 0.99 that can be said as 99 by 100. So, 99 by 100 that will come in your millimeter. That will come your millimeter. See, 99 millimeter if we are dividing into 100 parts. So, 99 division means 99 division of main scale is equal to your 100 divisions of vernier scale. So, 99 millimeter is divided into 100 division. So, our option number 3 is the correct answer. So, we can write third is the correct option. Now, come to the next question, question number 28. Question number 28. The dimension of a rectangular block measured with a vernier calipers is 10 mm by 20 mm by 5 mm. The least count of vernier calipers is 0.1 mm. The maximum percentage error in the measurement of volume of the cube is: first option 3.5%, second option 12%, third option 8%, and the fourth option 2%. See how to do this one. So volume is equal to your L, length, breadth into height. So percentage error in the measurement of volume written as delta L by L into 100 plus delta B by B into 100 plus delta H by H into 100. As per the given information, least count is your 0.1 millimeter. It means in any of the measurement, maximum error occurred by the measurement is 0.1. So 0.1 by length is your 10 into 100 plus 0.1, then length your 20 into 100 plus 0.1 length your 5 into 100. So we can simplify. So this become your 1 plus this become your 0.5 and this become your 2. So finally we are getting 3.5%. The maximum error in the measurement is your 3.5%. So our answer is your option number 1. So option number 1 is the correct option. This is the correct option, V in the percentage. Now come to the next question, question number 29. The question number 29, which of the following pairs have same dimension? First option or first pair is given L by R and CR. B option is given LR and CR. C option given L by R and root LC. D option given CR and L by LC. So first option is your A and C, second option B and D, third option A and D, and fourth option A only. Now see the correct answer. Since in all the options we are using LCR, we will use or we will calculate first dimension of L, C and R. L is the self inductance, that is your flux by I. Flux is your B into area by I. B we can write F by I L into area L square. This further written as dimension of L is equal to dimension of force M L T minus 2 L square 1 cancel L and I become your B. B is your F by I L and 1 I will be left, that is I square. A square MLT minus 2 and L square. So this will be your M L square T minus 2 A minus 2. This is the dimension of L. Then dimension of C. C is your Q by V. Then Q is square by work done. Q is your A square T square and work done ML square T minus 2. Then the dimension of this here M L minus 2 T4 A square. This is the dimension of C. Then resistance dimension. Resistance is your V by I. V is nothing, W by Q into I. W is your ML square T minus 2 and charge. Q is your I into T, A square into T. So this will be your M L square T minus 3 A minus 2. So, these are the dimension of our option. Now, see the first A part. A part L by R. L by R, just check it. L by R. So, when we are looking L by R, ml square cancel, T minus 2, T minus 3, T. So, this will be your T. And second is given a CR in a RC. CR, see the dimension of CR, product of R into C. M here cancel, M here minus 1 because this will come in denominator. Cancel, this is also cancelled, this is T, only T left. So, this have same dimension. So, A is the one option correct. Now, come to the B. In the B, LR and CR. LR dimension. The dimension of L into R. See the M square L4. So, M square L4 T minus 5 A minus 4. This is your LR. Then check it your CR. When we are doing CR, dimension will be your dimension of T. So, B as this pair is not matches. First A is matching. Now, see the C option. See L by R and root over LC. L by R already we have found, that is T, and root over LC, check it, L into C, L and this is C, L into C, cancel, LL cancel, T square only left, T square to the power 1 by 2, that is also your T. So, in the C also A and C pair is matching. Now, the D. In the D option number 1 your RC into R. C into R already we have found dimension your T, and another your L by LC. This have dimension your 1 by C. So, 1 by C we can write here just M L square T minus 4 A minus 2. So, all of these options what we found, pair in the A and pair in the C, these dimension are matches. So, A and C. So, which option? The option number 1. So, finally, your answer, your option number 1 is the correct option. Question number 30. The least count of a stopwatch is 1 by 5 seconds. The time of 20 oscillation of a pendulum is measured to be 25 seconds. The maximum percentage error in this measurement is, first option your 8%, second option your 1%, third option your 0.8%, fourth option is 16%. See the solution here. As it is given, the least count of a stopwatch, in a maximum error it can occur, that is your 1 by 5 second or 0.2 second, and it is given in 20 oscillation it occurs in 25 second. So, time period. So, time period as T is your 20 oscillation in 25 second. So, 25 by 20, that is your 22.5 by 2 or 1.25 second. This is the time period. So, percentage error is equal to your delta T by T into 100, delta T 0.2 to your 1.25 into 100. So, this is your 20 by 1.25 and 20 by 1.25 From that we can simplify. This is your 20 by 1.25, 2000 by 125, 25 5 ja, 25 80, then 16, this here 16. So we are getting the answer 16%. So maximum error is 16%. So correct option your option number 4. So answer is your correct option, your option number 4 is the correct. So this is the question number 30.